Hey y'all, it's day 3 of chapter 7, dividing radicals. All right, so the first thing we're going to do is, according to the quotient rule here, is that we could simplify our radical when it is in a quotient. Remember, quotient means division. So here I can reduce the outside, so like 36 over 9 could become 4. And then since these are both fourth roots, I can reduce what they have on the radicand on the inside. So 1,250 over 2, I could make 625. And then I would reduce it. Well, I know that the fourth root of 625 is actually 5. So then 4 times 5 is 20. Boom. All right, so same thing on number 4. On the outside, I have 28 over 4. Which I can make 7. They're both cube roots, so I can reduce what's inside. So negative 16 over 2 would be negative 8. M to the 6 over m would be m to the 5th. And remember, when you divide like bases, you subtract the exponents. So then simplify. The cube root of a negative is a negative. Cube root of 8 is 2. If I have 5 m's, I can make one group of 3, and I would have 2 leftovers. So then on the outside, 7 times negative 2m is negative 14m. Cube root of stuck on the inside, we have m squared. All right, so on number 6, a little bit different. We have the cube root of 40 over 27. There's nothing I can do to simplify 40 over 27. So what I could do is break it apart into 2 separate cube roots, right? So that's like the cube root of 40 over the cube root of 27. And then I could work with those individually. So I know that 40 would go 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So 40 breaks down to 2, 2, 2, 5. So groups of 3, I can bring out a 2. The 5 is stuck. So I've got 2 cube root of 5 over denominator. I know the cube root of 27 is 3. I can't reduce 2 over 3, so that is in simplest form. All right, similarly on number 8, I've got 32w over 81. We've got the fourth root of that. We can't simplify, so we go ahead and break it up. So we've got the fourth root of 32w over the fourth root of 81. So if you want to do the easy part first, I know the fourth root of 81 is 3. If I didn't know that, I could just use my calculator and check it and see if it's pretty. If I check the fourth root of 32, that is not pretty. So I would break that up. So 32, I could go 16 and 2. 16 is 4 and 4, which is 2 and 2. Or if I would have known back here that the fourth root of 16 is 2, I could have just gone ahead and brought that out. So root of 4, here's 4 2's to bring out a 2, and this 2 is stuck. So I've got the w that was also in there. I have 2, fourth root of 2w, and then I can't simplify 2 over 3, so that is done. All right, so far on all of those, the denominator, the radical in the denominator disappeared. It was so pretty. What you're going to see happen now, that doesn't always happen. So like here, we have the square root of 8 over 15, right? 8 over 15. So I know that there are pairs in 8, but not in 15. So this would be the same as the square root of 8 over the square root of 15. I can't have a radical denominator. So what you do is you multiply by whatever that radical is in the denominator. Whatever you do to the bottom, you have to do to the top. And you can go ahead and reduce radical 8 first or not. It doesn't matter. So then if I have radical 15 times radical 15, I know in the long run I'm going to end up with just 15. Because if I take 15 times 15, well, then I'm multiplying it by itself if I think of it like this, 15 times 15. So then the square root is just what I started with, 15. And the numerator, the square root of 8 times 15 would be 8 times 15 is 120. So then I'm going to have to couple go out, single stay in. This board is tiny, so I'll go do that up here. So let's see, 120. Where do I want to go? I'm going to go 40 and 3. 40 is 4 and 10. What are we doing? Square roots? Perfect. So I can bring out a 2. 10 is 2 and 5. So I can't bring out anything else, can I? So I bring out a 2. Square root of 2 times 5 is 10. Times 3 is 30. I can look at my numbers out in front. My outsiders, 2 and 15. Can't reduce anything there. So that's it. That is a 0, not a 6. All right, so it's called rationalizing the denominator. You have to get rid of that radical in the denominator. If you remember, we did this with i's a little bit ago. So number 12, what I do see on number 12 is that I could simplify it a little bit first, right? There's nothing that's in 32 that goes in 3, but I could get rid of one of those a's to make it a little prettier. So this would be like the square root of 32a to the 4th over the square root of 3. So now I have to rationalize the denominator by multiplying by radical 3, because then that would be the same thing as the square root of 9, which then just takes me to 3. If you multiply a radical by itself, a square root by itself, you're going to end up with whatever the radicand was. On the top, 32a to the 4th times 3, we're going to be looking at the square root of 96a to the 4th. Well, I know the square root of a to the 4th is going to be a squared. I can bring out an a squared. 96, I'm going to have to break down. So let's see, 96, I could go 32 and 3. Yep. So then 32, I could go 16 and 2. So actually at that point, I know that the square root of 16 is 4. And then I trap a 2 and I trap a 3. So on the outside, I have 4a squared. Square root of inside, 2 times 3 is 6. So looking at my outsiders, 4a squared over 3, I can't reduce. So that is it. All right, number 14, you've got two options. You've got that radical 12 stuck in the denominator. I know that there are pairs in radical 12, so I could simplify that and then multiply, or I can multiply and then simplify. It doesn't matter, right? The square root of 12 is not going to be pretty, though, so it's not going to make it go away. So I'm going to go ahead and multiply by radical 12. So if I do that in the denominator, I do that in the top. So then I know radical 12 times radical 12 is going to give me 12 in the denominator. I go through. 3 radical 2 times radical 12 is 3 radical 24. Radical 6 times radical 12 is going to be radical 72. So now I'm going to have to simplify. So I'm going to just go up here and do it. So I have 3 radical 24. So I'm going to go 2 and 12. 12 is 4 and 3. So I can bring out square root of 4 is 2. 2 and 3 are stuck. So that's going to be 6. So outside 3 times 2 is 6. Radical inside 2 times 3 is 6. So I'm at 6 radical 6 plus, I have to do radical 72. I'm going to go over here for space. So 72, I don't know, I'm going to go 8 and 9. I know the square root of 9 is 3. 8 is 2 and 4. Square root of 4 is 2. This 2 is stuck. So 3 times 2 is 6. Radical 2 inside over 12. So on this one, I look at my outside numbers, right? My outside numbers are 6, 6, and 12. I can't reduce that. I can actually divide those all by 6. So it would become 1 radical 6 plus 1 radical 2 over 2. All right, so now on the next ones, you can see that they are binomial. So just like we did with i's not too long ago, you multiply by the same terms with the opposite operation. So like here, I would multiply by 6 plus radical 5. Do the same thing on the top, 6 plus radical 5. So 2 times 6 is 12. 2 times radical 5 is 2 radical 5. On the bottom, the radicals will disappear. 6 times 6 is 36. 6 times radical 5 is positive 6 radical 5. Back through by negative radical 5 times 6 is negative 6 radical 5. And negative radical 5 times positive radical 36 minus 5 is 31. And on the top, 12 plus 2 radical 5. I look at my outsiders, 12, 2, and 31. Not reducible. That is done. Right, so let's skip over this one, go to the one that's a little bit harder. So since like here, I would multiply by radical 5 minus radical 3, right, on top and bottom. But for time's sake, I just want to skip to the next one. I have 3 minus 4 radical 6, so I multiply by 3 plus 4 radical 6. Same thing on the top, 3 plus 4 radical 6. So 8 times 3 is 24. 8 times 4 would be 32 radical 6. Back through, negative radical 6 times 3 would be negative 3 radical 6. Negative radical 6 times 4 would be 4. Nope, my bad. Negative times 4 would be negative 4 radical 36. Denominator, 3 times 3 is 9. We go plus 12 radical 6, minus 12 radical 6, minus 16 radical 36. So when you simplify, those radicals are going to go away. You can see again, the insides cancel. Square root of 36 is 6. So then I can see 16 times 6. I end up down here with, where am I going to go? Negative 87. Numerator, square root of 36 is 6. So let's see, negative 4 times 6, this is going to be minus 24. So nice, 24 minus 24 cancels. 32 radical 6 minus 3 radical 6 is 29 radical 6. So then I look at my outsiders, 29 and negative 87. Actually, I can reduce. They're divisible by 29. That's a nice spell. So I get radical 6 over negative 3. So no radicals in the denominator. And that is day 3. That's Mrs. McKinney. See ya.